Right, did I give you your homework? I did. Revision exercise 5 and 3. Okay, no, that's fine. So we ended off here. With this here question. So let us go on to 4.2. 4.2, 4.2, 4.2. Okay, let's use that one. The probability that at least one household has at most one household has a cell phone. So here, what are we saying? Sorry, I can't hear you. Can you hear? I can't. Yes, we're still doing binomial. We're still doing binomial. The next question, though, we will be doing a different one. So this is obviously the probability of x here, that it is less than or equals to what? 1. At most, sorry, no. So yes, less than or equals to. I don't know why I'm putting more than. Less than or equals to 1, isn't? So here, what are we then saying? What are we then saying? What are the potential answers? We're basically saying it must be less than or equal to 1. What are the values that we can get? Remember, this is discrete, isn't it? So discrete is only whole numbers, isn't it? So what are the numbers? If we're saying equals to 1 or less than, what are the numbers that we can get for x? 0 and 1. Okay, so we're looking for the probability that x is equal to 1 plus the probability that x is equals to 0. Makes sense? So again, we then go and we say, okay, fine. Now we need to find the probabilities of these two. We have already calculated the probability of 0, isn't it? That was 0.000219. Now we need the probability of x equals 1. Did we do that anyway? No. Okay, so it's fine. So then let's do that. Probability that x is equals to 1. Then we go back to our binomial formula. We are basically saying is equals to, we still have how many observations? 7, huh? 7, yes. And x is 1. And the probability now is what? What's the success probability? Yes, 0.770, yes. To the power 1 times 1 minus 0.70 to the power n, 7 minus 1, which is 6. Okay. What do we get when we work that out? Okay. So then we have to come back here and add those values. So 0.00357721. And what do we get when we add those two together? What is our answer? Okay, is everybody getting the same answer? You getting the same answer? So it's 0.0037908. Okay. Perfecto. Perfecto. Right. So then, yeah. So then we then move on to the last one. And here, what are they saying? They're saying the probability that all 7 households have cell phones. So again, is our formula. So we're basically saying the probability that x is equals to 7, isn't it? Am I right? Okay. Which is equals to 7c7 times 0.70 to the power x, which is 7, times 1 minus 0.77 minus 7, which obviously gives you 0. What do we get here? Or maybe let me just give you the answer so that we can make sure we have some time to get through the next one. So here you're going to get 0.082354. Okay, that's what your final answer should be. Okay, but I'm sure we're now getting the gist of the binomial questions. I think the tough task is identify. Okay, and I'm sure now with the practice that we've already done, you guys will be able to insert the values, because now you know, okay, x is this, n is this, and so forth. But don't stop here, guys. Let's keep practicing, isn't it? So we just want to. Okay, so then we want to go to revision exercise 2. Okay, so now just in the interest of time, I will just tell you that here the formula that they're using is now the one that you mentioned earlier. Poisson. Yes. So now I'm just trying to retrieve the formula. Where's the formula? There's the formula. And this formula was scaring my students yesterday because they were panicking. They were saying, my goodness, that what we are supposed to do. And do you know, to my surprise, I think that this is actually easier than the binomial. Once you understand what is going on. So where shall we paste this thing? Maybe let me paste it right here at the bottom. Yeah, it's fine. Oof. Okay. Let's reduce that. Okay, so let's zoom in there. Ooh, where am I? Okay, right. So here we are. So let's first read the question actually. So firstly, they say here, the surface of a car is approximately 15 meters squared. Records at a certain factory show that there is an average of 0.2 paint blemishes per square meter of painted surface. What is the probability that a new car will have less than 3 paint blemishes in total? Okay, so they want us to find the probability that a new car has less than 3 paint blemishes in total. Okay, right. How do we apply this Poisson distribution or formula? So this upside down looking V or Y, actually, upside down looking Y, is the mean number. And we know mean is the average. So the average number of occurrences, okay, of a given outcome of a random variable, that being X, for a predetermined time, space, or volume interval. Okay, predetermined. Right, so that's an average. If I'm to make it simple, it's an average. Okay, average number of occurrences. So here they've given us an average number of occurrences. We've got 0.2 blemishes of paint per what? Meter square. That's an average. Can you see that? Okay, so this then is obviously going to be our, all right, depending now on how much space we have. Okay, so how much space do we have? They've told us a car approximately has 15 meters square. So this would be times 15 meter squares to find out how many blemishes on average for a car which approximately has that much space. All right, or should I say surface? Okay, so there you can start to see what the time, space, and volume interval. It's been predetermined. So when you say 0.2 times 15, what do you get? You get 3. So our average that we're working with is 3. Okay, so we have that so far, but we also need the other variables. So E is your mathematical constraint, approximately equal to this. Okay, but we know we have E on our calculator, so we just plug and play. X is the number of occurrences of a given outcome for which the probability is required. Okay, so what did they say here? Is less than 3. So we're saying the probability that X is less than 3. So less than 3. Okay, what is the probability of this? Okay, now we have all our relevant information. Now we need to insert it into the Poisson formula. Okay, now this is why you guys need to go and practice, because you need to make these formulas your own. Does that make sense? I don't like the formula here in the slides, just the way that it's presented. Does that make sense? Okay, I prefer to have it written out like so. I like to have it like this, to the power x, and then times e to the power, I don't know what this thing is called. Anybody know what this upside down y is called? Okay, right. Divided by x exclamation mark. I don't know, that just looks cleaner to me. But you will literally see it's the same thing. Only thing that I've done is I've reversed these two. And remember, when we say 2 times 4 is the same as 4 times 2, isn't it? It's exactly the same thing. Just making sure we're recording. Okay. Hallelujah. How's that better? You'll see when we insert values. You'll see. Let's insert the values. So here, this upside down, this average, we said it's what? Let me use a brighter color. I was really expecting you to ask something different. That was the last thing that I thought you'd expect. And then here they said is less than 3. So basically we are saying, what are we saying? The probability here, we didn't do this. We are basically saying the probability of it being equal to 0, probability of x, sorry, equal to 0, plus probability of x equals to 1, plus the probability of x equals to 2, right? Because we said less than. So you basically now have to calculate all of these and add them together. So first one, 3, 0, right, times, okay, but I don't want to put the times because it might confuse it with the x. So e then to the power negative 3, because remember the upside down y is 3, isn't it? Then divided by x, which is 0 to the power 1. Okay, so that's the first one. And remember, we're just adding all 3 of these. So you guys, if you could work out that whilst I then put together the second one. Second one, we're saying same thing, 3, our average upside down y, but this time to the power 1, because x is now 1. I'm over here, isn't? Then times e negative 3 divided by 1 to the power 1. Okay, you get your answer here. Then the last one that we need to add is then 3 to the power 2 times e negative 3 to the power negative 3. And then here's 2 exclamation mark. You get the values over there. Minus 3 on here, ne? Right? Remember, if you look at the formula, it says what? Minus the upside down y. And we know that upside down y, we calculated it to be 3. Okay. Come, guys. Come, we're in a race against time. What is our answer for the first one? 0.04978. 7. Just check if my answer is right. Is that right? Okay. Then the next one. 0.0498. You can. Remember, at the end of the, well, I would advise don't round off here. Round off at your final answer. Okay. But if you are working to 4 decimal place, it's going to round for you. Does that make sense? So I'm not going to dictate to you what number of decimals to work to. That you can decide on your own. I recommend doing it 6, but it's up to you. Okay. So the second one. Okay. And then the last one. Okay. Yeah. 6322312. 1493612. Oh, 61. Like that. 612. Okay. So when you add all of those, what do you guys get? Okay, I'll tell you what you should get. You should get 0.423190. This is your final answer after adding. Okay. Yeah, but I think you definitely, we have the right, you've calculated the right stuff here. So yeah, okay. Happiness there. So now we go to the next one. And I'm just going to erase this now. Okay, the next one, what are they saying? Okay, I won't erase the calculation of our average occurrences. I think we can leave that there. So with this next one, let's use blue. We are saying in a book, 2 misprints occur on average per 100 pages. Determine the following probabilities for a book of 400 pages. Okay, so your average is going to be specific to the relevant question. Does that make sense? So here we said, okay, so to get our average for this second question, we're then going to say, we get 2 mistakes, so 2, but this is per 100. Okay, so we just use probability, proportion. We want, what is our average for 400 books? So basically what we want divided by what we have times what we have. Okay, and you'll see that should give you 4 times 8 times 2, which will give you 8. So our average here is 8. Okay, we have that out the way. Then it says the probability of finding 5 or 6 misprints for a 400-page book. So we're basically saying, what is the probability of X being equals to either probability of X, no, let me take it one step back. We're basically saying it must be 5, right? X and then 6. So it must be either equal to 5, right? Or 6. Yeah, which is the same as saying probability of X equals to 5, or, so we can say plus probability of X equals to 6. Can you see that? Okay, so then we say, okay, so we now need to do the calculation for these 2 probabilities. Okay, so we go back to our formula, where then this formula, that is, okay, not this bit here. So we then say, okay, when X is equals to 5, we are saying our average, no, let me not do the formula again. We're saying 8 to the power 5 times E minus 8 divided by 5 exclamation mark. If you guys can calculate that, number 1. Number 2, probability of X being equal to 6. We're saying 8 again to the power 6 times E minus 8 divided by 6 exclamation mark. Now can you see why I say this is, I think this is better than the binomial? That can, yeah, it can be, but I think the challenge with, and I say this probably for all of statistics, is making sure you understand what they want. Sure, because if you get lost there, it's gonna be a hectic one. So what are we getting here? 0, 0366. And here? Yes, 138. Okay, and when you add those two together, you should then get 0.2137 if I round off to 4 decimal place. That's not what you guys are getting. Wait. Let me also just check. Yes, this is what I got. 0.0916 is what I got as well. But yeah, just check your decimals here. So I'm sure you got this bit. It's just if you're working to 4, you would have gotten the 6 as she highlighted. But if you're working for more than that, I'm sure it was probably 5 something something, isn't it? Okay. What are you getting? Because I know you got more decimals. Okay. But you can now already see that if you add these two, you should get that or something close to that. Yeah. Okay. Right. So then we have finished this. No, we haven't finished the second one. So the second one, they say the probability of finding at least one. Because remember, probability is a chance. Né? It doesn't mean we will always find mistakes, isn't it? We might not have any mistakes whatsoever. So we're saying at least one misprint. At least one. So we are basically saying the probability that we will have one mistake or more. Isn't we're saying at least? You're so happy to be here, né? So we're saying the probability of x being at least 1, all right, or greater. Okay, which is the same as what? The probability of 1 minus the probability of x equal to 0. Because we're saying we're happy with any other value that is 1 and more, isn't it? So this at least is a little bit easier from the perspective of, okay, so if we do our calculation here, we quickly say, okay, going back to our formula again, we're saying we know our average is 8. We know that x is then obviously 0 because we want to calculate this, isn't it? Then we're saying times e to the power 8, negative 8, divided by 0, exclamation mark. What do we get here? Okay, in the interest of time, here you, yes, Yebo, 335. Okay, and then you obviously just minus from 1. So 1 minus this.
So basically, like every answer we must 1 minus.
Not every answer. It depends on what they're asking. It depends on what they're asking. 0, comma, 5. Okay, so there's a high probability that we will get at least one blemish. Can you see that? Okay, this is like saying 99.66. You can even make it 67 here percent. Okay, but anyway, let's move on. So now we're done with the second bit. Okay, and these ones are slightly shorter. So let's see what we're saying in question 3. All right, the average number of traffic accidents per 7-day week on a certain station, or sorry, a certain section of highway is equals to 14. Based on this, what is the probability that you will be, that there will be, 4 accidents on Monday of a specific week? Okay. So again, the first thing we want to calculate is our average. So our average, they're telling us, is equals to 14. But that's 14 accidents per 7-day week. All right. And here, when they're saying they want to calculate the probability only for Monday, Monday is how long a time interval? Is it 7 days? It's what? It's 1 day, isn't it? So we need the average per day, isn't it? So obviously 14 divided by 7 will give you, it will give you 2. So 2 accidents per day. Okay, that's our average. Then we say to ourselves, okay, sharp, we've got that. Now we want to assess the probability that we have 4 accidents. We don't want more, we don't want less, just 4 accidents. So here we're looking at the probability of x being equals to 8. Sorry, not 8, 4. 4. So then we plug that into our formula again, which is right here for those who just decided to join us recently. You know yourselves, yes. So here the average is 2 to the power x, which is 4, and then minus 2, our average, divided by 4 exclamation mark. And if you calculate that, what is our probability of having 4 accidents on a Monday? I'm trying so hard to win you over to this. Am I winning? Is it not easier, my friend?
No.
It's not. You prefer binomial. I accept defeat. What is the answer?
0.09.
0.09.
0.022.
0.023. Okay. Right. Right. Okay, sharp. And that is your question 4. Now let me quickly get to question 5 so we can do the register and go home. Well, neither of us is going home. You guys have class. You have class. And I know you're good students. You attend all your classes. Jim is a real estate agent who sells large commercial buildings. Because his commission is so large on a single sale, he does not need to sell many buildings to make a good living. History shows that Jim has a record of selling an average of 6 large commercial buildings in 180 days. So there's our average. There's our upside down Y. We are saying how many? 6. But this is 6 buildings over 180 days. Okay, so what else are they saying here? In a 60-day period, what is the probability that Jim will make no sale? Okay, so we are then saying, okay, but we're not interested in 180 days, we're interested in 60. So we need a 60-day average. So again, proportion, 6 times 60 over 180. What do we get? This is the same as saying 1 over 3, yeah? Yes, 1 over 3 times, so then into that, there's going to be 2. So two large buildings for 60 days. Okay, all right. We have our average, and they're saying he makes no sale. So we're looking at the probability of X equal to 0. 0. No sale. We go back to our formula. We say, okay, our average is 2 to the power 0 times E to the power negative 2 divided by 0 exclamation mark is equals to 1. Is it 1? No, don't you mean the exclamation mark is 1? Is the answer 1? E is here. What is the answer, guys? The answer is 1. Really? That sounds about right. 0.1353. So I think here, this, if you go, let's do it together, ne? I want to make sure no student left behind, ne? 2 to the power 0 is 1. This is 1. Let me just do it here. 1. Then e to the power negative 2. Where's my e? Where's my e? And then we said negative 2. Okay, so there I'm going to erase this here. I'm getting 0.135335. Okay. And I'm going to just erase this here. If we throw into our calculator 0 and then your exclamation mark, this is where you get 1. So 1 minus 0.135335 equals 0.864665 divided by 1. Oh, thank you for rescuing me. It's times. And I was getting the wrong answer, so I was now also getting confused. So then here. Yes. It stays the same. Yeah, it's time to go home. 5, 3. Okay. Makes sense. Okay, so then let's quickly do the register.